All right, we've gotten in a little practice so far with solving algebraic equations. So now we're sort of going to slowly ramp up the degree of difficulty. So this next example deals with something that our notes refer to as a fractional equation. So the variable is actually in the denominator of fractions. So we're going to clear it out the same way we've done previously with stuff. We'll see in an example here in just a second. But the big thing is we often kind of skip over that very last step listed in our process. The check to make sure your answer works out. That's going to be particularly important in fractional equations for reasons that we're going to see in a moment. I'm actually going to skip over the first example in the notes file and jump to the second one because it gets at the point that I was wanting to take a look at. So let's take a look at this bad boy. So we have 2x minus 1 over x minus 3 equals 4 plus 5 over x minus 3. All right. So the good news in this instance is we don't need to worry about finding a common denominator. You do in the previous one, just like a little. It's not too big a deal. But so in this case, we want to multiply both sides of this equation by x minus 3. So if we multiply both sides of this thing by x minus 3, my camera is trying not to focus for some reason, so I'm trying to stand still and give it a chance to draw back in. So we want to multiply by x minus 3 here. So when we do that, it's going to go away here in the denominator, that second guy, completely, right? So we have 2x minus 1 is all that's left on the left-hand side. That's good. Over on this side, we multiply by x minus 3. Remember, each of these two things connected by that addition need to get hit with a copy of x minus 3. So we have 4 times x minus 3. I put it in parentheses just for, because you should. But, and then 5 over x minus 3 times x minus 3. The x minus 3 pieces are going to cancel, and all I've got left is just plus 5. Awesome. So now, no more fractions. All right. So I need to distribute this 4. Go ahead and get rid of those parentheses. So we have 2x minus 1 equals 4 times x. It's 4x. 4 times a negative 3. That would be negative 12. I'm going to go ahead and combine the negative 12 with this plus 5 that's right here. So we get 4x minus 7 at this point. Now we're basically back in the situation that we were in before. We need to get all the x terms on one side. I'll go to the left. Then get the number stuff over on the right-hand side. So if I subtract 4x from both sides and also add 1, so that's going to get rid of that 4x right there. And I have 2x minus 4x. That's going to give me negative 2x on the left. Over here, now that guy's gone, we have negative 7 plus 1. That gives me negative 6 on the right-hand side, and over here, negative 1 plus 1. They vanish in a puff of logic. So that's all we got left. And so now you divide both sides by negative 2. X is negative 6 divided by negative 2. That gives me 3. And you might say, okay, we're done. But wait, Professor Carroll hasn't put a box around his answer, so that seems, why hasn't he done that yet? It looks like he's done. Here's where that go back and check your work thing is important. Because now, if you take this value 3 and try to plug it back into this original equation here, what happens? Pause for a moment for you to think. Wait a second. Yeah, the denominators in those fractions before would be 0. And hopefully that sets off some kind of warning bell in your head. Sirens are going off, and that is the one thing math teachers never, ever, ever do, right? Is divide by 0. So that blows up if you try to plug it back into the original equation. So yeah, he cannot be a solution to this particular equation. So what we would end up saying about this as a result is that the equation has no solution. So, and I'll put a box around that because that is in fact the appropriate answer. There is no value for x which will satisfy this original equation because the only candidate, so to speak, makes the divisions go kerblooey. So All right, so that's fractional equations. As it turns out, like I said, I'm going to leave the other fractional equation for you to take a crack at. Feel free to shoot me questions about it. But it turns out in that instance, when you go back and check, you're okay. Short story long. I got that backwards. Anyway, so moving on. So we want to take a look at some equations. As it turns out, there are actually very few scenarios out in the real world where you can limit things down to where there's only one variable. Generally speaking, most of the equations we're going to see are going to have multiple variable quantities floating around in them. And as it turns out, you can kind of isolate any one in terms of the other. So the examples we'll see in this first section, we only have two variables to worry about, but Anyway, so we've got, this is kind of an application. We're being told here that this is the relationship between some company's profits and how many of whatever it is they manufacture they sell. So we have 10x minus 8p equals, I believe it's 800. Yes, double checking to make sure I'm not screwing something up. Okay, so now there's a few different pieces to this. So the first part of this asks, well, how much do we need to sell if we want to make a profit of $150? So for that first bit, we're told that P is representing the profit. Whoa, that is super blurry. Okay, it's coming back into focus. Awesome. All right, so now we feed in 150 for P, and then we've got to solve for X. So we have 10x minus 8 times 150 equals 800. So if you work that out, 8 times 150 should give you, what, 800? 1,200. So you have minus 1,200 here. Don't panic if you need the calculator for that. I get it. So then I need to add that 1,200 over to the other side. So we have 10x equals 800 plus 1,200 would give me 2,000. So to get x by itself, we do that inverse operation thing. We divide both sides by 10. 2,000 divided by 10 gives us 200 of whatever it is our company is manufacturing for sale. So 200 units. Great. So now we know to get that what seems like a relatively meager profit margin. So for maybe a small company, maybe this is only like a day. It still seems, I don't know. Anyway, so the next part says, let's get P by itself in this equation. So the algebra term for that is solving for the variable P in terms of the variable X. So we want to get P by himself in here. So we get P on its own. So we can just basically move things around so that P is in fact by itself. So first off, we've got 10x minus 8p, so I'm going to subtract 10x from both sides. So that's going to give me all that's left on the left-hand side, no pun intended, is negative 8p. Then we have 800 minus 10x. If you wanted to rearrange that so it said negative 10x plus 800, that's fine. But this does the job. All right, what's left to do to get p by itself? We've got a multiplication by this coefficient of negative 8. We've got to divide, right? So you have 800 minus 10x divided by negative 8. And now you can break this up if you like. That's the way I'm going to do it because I don't like keeping this written like with a big awkward fraction. You can work with it like this. If you were trying to type numbers into your calculator, do remember you'd want parentheses around the top of this fraction or else it'll screw things up. So in any case, so we get negative 100. The two negatives, negative divided by negative, they kind of cancel. 10 divided by 8 you can write as a decimal, or I'm just going to write it as 5/4 x. So we have 100, or negative 100 rather, plus 5/4 x. All right. So now, for part C, at the bitter end of this, it says find the profit when 240 units are sold. So we've got now an X value, because that's the number of units that we've sold, 240, right? Okay, so now we just feed in negative 100 here, plus 5/4 times 240, And we can do work out the arithmetic. And if you're using a calculator, that's fine. I get it. There's no judgment here. So, but the way I'd work this out, 240 divided by 4 is 60. 5 times 60 is 300. Negative 100 plus 300, we get a $200 profit. So, kind of what you might hope, right? If we sold more things, the profit should go up, right? So hopefully, that stands to reason. All right, so we played around with some more algebraic techniques here. We saw this fractional equation thing. We've seen what to do in a scenario where there are multiple variables hovering around. So I was going to try to work one more example in here, but I'm kind of butting up against where I've run out of time before this video recording will end. So we're going to go ahead and press pause and come back to see an example where we actually need to come up with the equation. So stay tuned.